Okay, here's a question from page 883. Again, we're wanting to calculate the Gibbs free energy, the standard value at 298 Kelvin. Again, so another formula for calculating Gibbs free energy. Okay, we've got a I2 plus Cl2 yields 2 ICl. This time they gave you a Kp value, so an equilibrium constant. Okay, so there's a relationship between equilibrium constants and Gibbs free energy. Okay, and our equation we're going to be using there is delta G of reaction equals the negative RT ln of K. All right, and K here may be a Kc or it may be a Kp. We use R again as 8.314. We use temperature 298 Kelvin, and then we take the natural log of our Kp value 81.9. Okay, our delta G of reaction comes out to be a negative 10,914.9 joules per mole. Okay, I went ahead and put it back into kilojoules, so negative 10.9. Now, what that means, what the relationship between K and delta G is, if K is greater than 1, which in our case it is because it's 81.9. If K is greater than 1, then delta G is going to come out to be a negative value. Delta G is negative, that means the reaction is spontaneous. And since K is greater than 1, it's going to be spontaneous in the forward direction, not in the reverse direction. Okay, so with reversible reactions that reach equilibrium, there's a connection between K and delta G. When K is greater than 1, delta G is going to be negative, which is going to mean that your reaction is spontaneous in the forward direction. Okay. Now, if, for example, your K was negative, less than 1, and your delta G would then be positive, that would mean that the reaction is only spontaneous in the reverse direction. And then when K is equal to 1, then we know we're at equilibrium. Okay, delta G is going to automatically be 0 when any reaction is K equals 1 at equilibrium. Okay.